You're watching the fourth lesson on probability. This lesson will introduce a new concept of dependent events. Um, this is where probability starts to get a little trickier because dependent events have different probabilities and the event of one can affect the other. So if you recall from previous lessons, independent events are what? Right? What are independent events? Well, independent events are events where the outcome of one event does not affect the outcome of another. Right? The outcome of one event does not affect the outcome of another. So if I was talking about dice and I was rolling two dice, I could potentially get 1 to 6 on one die and 1 to 6 on the other die. They're independent because this die doesn't affect this die, right? If I get a certain number on this die, then this die's probability doesn't change. It doesn't matter if I get a 2, 3, 4. The probability of any number on this die doesn't change. So any one number is 1 over 6, and any one number on this one is also 1 over 6. And so they are independent of each other. Their rolling a die doesn't affect the other die. Their probabilities don't change. So you say they are independent or independent events. Another example we could look at is having a box of marbles. You have 5 marbles in the box, and you have 2 different colors. As you can see in the picture here, you have 3 blue and 2 red. Okay, so the question's asking, if you were to pull out, what is the probability of pulling out 2 marbles? So you pull out 1 marble, and then you put it back, and you pull out another marble, a different one. What is the probability of pulling out 2 marbles? What is the probability of pulling out 2 marbles? Well, first we have to ask ourselves, how many events are there? Right? Well, we pulled out 1 marble, then we put it back. Then we pulled out another marble, and then we put it back. That's 2 events, which means if we have 2 events, we have 2 different probabilities. A common mistake people will make will be to go, oh, well, we're looking for 2 blue over a total of 5. So that would be my answer. No, that is not correct because you're treating this as though there are only 2 marbles, even though there are 3 of them, and this over 5, yeah, you're correct, there's a total number of outcomes of 5, but there's more than one event. Another mistake someone would make would do this. They would go, oh, 3 blue over 5. Well, you're right. That is the probability of pulling out 1 marble, that is blue, right? Out of a total of 5 different marbles, a total of 5 outcomes, you could pull out 3, potentially a 3 in 5 chance of pulling out a blue marble because there are 3 blues out of the total of 5. But there are 2 events. You're pulling out a marble, putting it back, and pulling out another marble. So the first event is a 3 in 5 chance. What is the probability of pulling out the second marble being blue and having it be blue? Well, it's also 3 over 5, right? Because, again, our sample space is 5, total number of marbles. The probability of what we want, which is blue marbles, we're looking for blue marbles, is 3. There are 3 blue out of 5. So 3 over 5 is the probability of pulling out a blue marble. And when we put the marble back, again, the total number of marbles have not changed. We put the blue back. So there's still 5 total marbles as our second sample space. And again, we still have 3 blue marbles to 2 red. So we still have 3 out of 5. And so from our previous lesson, we know if we have 2 events and we're trying to find the probability of both of them happening, you just multiply the fractions. And you multiply fractions by just multiplying the tops, 9, so 3 times 3 is 9, and then multiplying the bottoms, 25. And there's your probability of a 9 in 25 chance. If we were to quickly pull up their calculator, 9 divided by 25, that's a 0.36. So you have 0.36 chance, or a 36% chance of pulling out 2 blue marbles out of a box of 5 marbles. Now, one thing to note carefully. The reason why this probability didn't change is because we put it back. We put the marble back. So our sample space never changed, right? The total number of outcomes, it didn't change because when we took a marble out, that was our event, then we reset the event by putting it back. So our sample space doesn't change. And the total number of blue marbles don't change either, because we started out with 3 blue ones, we pulled one out, and then we put it back, so nothing changed. So these probabilities don't affect each other, right? Because I put the marble back, the probability of the blue stays the same. So we can say that these events are independent because pulling out a blue marble doesn't affect pulling out another blue one because we put the blue back, right? Dependent events are where the outcome of one event affects the outcome of the other. So dependent events are where the outcome of one event affects or changes the outcome of another. So basically what it's saying is you do one event, and that event changes the probability of the other event. So let's look at an example to make it clear. Again, we have the same box of marbles. We have 5 marbles in total, 3 blue, 2 red. This time, we're still looking for 2 blue marbles, but when we pull a marble out, we're not putting it back. Okay. So what is the probability of pulling out 2 blue marbles if you take out a marble and don't put it back? Okay. So we look at the first probability, and just like before, we have 5 marbles in total. So we have a sample space of 5, right? We have a sample space of 5. And where we have 3 blue marbles. So we have a 3 in 5 chance of pulling out a marble. That's our first event. We pulled out a marble. Okay, but we didn't put it back. We did not put it back. So now we have this box. Same box, but we pulled out 1 marble. And we didn't put it back. Okay, well, what is the probability of pulling a blue one out now? Well, what is the sample space? What are the total number of outcomes? Well, there are 4 marbles, meaning that there's a sample space of 4 because a total of 4 outcomes. And there are only 2 marbles left, 2 blue marbles left that we can get. Right? So the probability of this one is different than the probability of this one because when we pulled out a blue marble, we changed the probability of getting a blue one again. We changed the probability of getting blue again. So the event of the first one changed the probability of the second one. If we look at the previous one, because we put the marble back, the first event that took place didn't change the probability of the second event because the marble came back. So we reset the box. In this one, when we pulled the blue marble out, that 3 in 5 chance, well, to pull out a second marble without replacing that blue one, well, we've changed the total number of marbles. And we've also changed the total number of blue marbles. So now we have 2 over 4 instead of 3 over 5. So now we have a different probability. And again, same thing applies. We now multiply through because we have 2 events. 3 times 2, 6. 5 times 4 is 20. And then we're not done. We can divide it by 2 to get 3 over 10. So here, in our previous example, we had a 36% chance of getting 2 blues with replacement, by replacing the marble. We have a 36% chance. But by removing a marble and keeping it, and then pulling out another one, we have now reduced the chance to 0.3, or 30%. 30%. You should know how to convert decimals into percent. Remember, you just take the decimal and go 1, 2. Well, 3 and 0, there's an invisible 0 here. You don't write zeros if they're after the last number because it would go on forever, right? So you'd go here and here, you'd end up with 30, so 30%. So the event of the first one changed the outcome, the possible number of outcomes for the second one, and changed the total probability. Right? So here we look at this review. Pulling a blue marble first has a probability of 3 over 5. Pulling out a second marble without, again here, without returning the first marble is now 2 out of 4. You have to be very careful. You have to think about the question. Does the first event change what you have, change what you started with? Right? If you pull out a marble and then put it back, you didn't change anything. But if you pull out a marble and don't put it back, you've now changed your sample space. You've changed your probability. And so because one event changed the other event, you say that these events are dependent because they affected each other, or one affected the other. So you say they are dependent events. So identify these as independent or dependent events. For homework, a teacher instructs her students to choose a city in their province for a social studies project. Since they live in a small province, repeats are allowed. Is that a dependent event or an independent event? Well, if you think about it, if any student could say any city in their province, and they could say the same city, that means the total number of cities that they could pick from doesn't change. So let's say there were 5, let's say there were 10 cities. 10 cities in this province. And there are 20 students. There are 20 students. Well, each student could pick a name of a city. But because you're allowed repeats, 2 people, for example, could say, let's say, Calgary. 3 people could say Edmonton. 4 people could say Red Deer, right? So it doesn't change the total number of cities that they could pick from. It would be dependent if repeats were not allowed. It would be like having a marble where each marble was a city. If you weren't allowed to repeat the city that another student chose, then you're taking away that city out of the total number of cities you could pick. So if repeats were not allowed, you're taking away from the total number of cities you're allowed. So if repeats are allowed, it's independent. If repeats were not allowed, it would be dependent, because the event of a student picking a city would change the outcome of another. Okay, so counselors at a summer camp are assigning beds to the campers. Rudy is assigned a bed, and then Brody is assigned a bed. Is this dependent or independent? Well, if you think about it again, you should say it is dependent. Why? Well, if Rudy is given a bed, Brody isn't going to be given the same bed, right? So if there were 4 beds in total, right? Well, Rudy's going to get a bed, right? He gets assigned that bed. Well, before, he could have been assigned any one of these 4 beds. So he had a 1 in 4 chance of getting any one bed, right? This is a probability of 1 in 4. But now Brody afterwards, then Brody is assigned a bed. Well, he can't be assigned to the same bed, so he can only get one of these 3. So he has a 1 in 3 chance of getting any one bed left over. So the probability just changed. So you say these are dependent because when Rudy gets a bed, Brody has fewer options to get. And that's it. So this will quickly review. I highly recommend this video. It goes over independent and dependent events very well. Yeah. Try these questions on your own and try and solve those questions because they go over dependent and independent events. So 2 cards are chosen from a deck. of 52 cards without replacing it. Find the probability that one is red and the second is black. Well, key trick here when you're trying to figure out if it's dependent or independent, because that should be your first step. Always try and figure out if you're dealing with independent or dependent events, right? And make sure you mentally note it or write it down somewhere so you don't make the mistake of changing the probability when you didn't have to, or not changing the probability when you did have to. So key here is not replacing. You're not without replacing. So you're taking two cards out of 52, right? And you're looking for red and black. Well, half the cards are red and half the cards are black, right? So any one red card, you have a 26 out of 52 chance of getting a red card, right? A total of 52 cards, 26 of them are red. The second one, right? Now you've pulled out a card though, so you have fewer cards. So your sample space went down by 1. So you have 51 now. You have 51 cards instead of 52 because you took a red card. Now again, the number of black cards didn't change because you pulled out a red card. So then it's still 26. So you made it just a little bit more likely to get a black card the second time. And so you can multiply through and you can get your answer. Right? So I'm not going to do them. You can use a calculator for this. We've moved past grade 7 review, so we can start using our calculators. So we have another deck of cards question. From a deck of 52 cards, what is the probability of choosing 2 kings without replacing the first card? So if you have a deck of cards, or if you don't know how many cards or how many kings are in a deck of cards, just you can Google that and you can solve this one on your own. Same with this one. Okay? So that will conclude the lesson for dependent probabilities. I highly recommend you review this multiple times. It's probably the hardest part of probability. And hopefully you get a good grasp of it. If you don't, please find me in class and I'll help you explain it. See you next class.